Okay, so we're going to go ahead now and begin with Chapter 1, Section 1. So we'll look at 1.1 here. Now, Chapter 1 is all about linear and nonlinear equations. The first half talks about linear equations, and that's 1.1 and 1.2. The second part of this chapter is the quadratics. So we're going to first talk about the difference between an equation and an expression, and then we'll talk about linear versus nonlinear. So just as a quick review, what's the difference between an equation and an expression? Well, the difference is the equal signs. So equations, they have an equal sign, and they can be solved. Now, when I give you definitions, I try to give you definitions in my own words, definitions that I think you can understand. If you want a formal definition, you can look them up in your textbook. But these are definitions that are in my own words, and I think they make it easier to understand. So in equations, they have an equal sign and they can be solved. So let's look at a couple of examples. Here's an example of an equation. 4 times 2x minus 9 equals 3. So this is an example of an equation. It's an equation because it has an equal sign. How do we solve this equation? Because it's solvable. Well, we solve it by distributing the 4 through. And again, this should be review. So distribute that 4 through. So that makes it an 8x minus 4 times 9, that's 36. And that equals your 3. We need to solve it. So what do? We get the 8x by itself. So we're going to add that 36 to both sides. And doing that, that gives you 8x equals 39. And we divide by 8. And we now have solved it. And we have x equals now 39 over 8. We're going to leave this as a fraction. The only time you use decimals is when the question has decimals. Otherwise, you'll keep the fractions. And that's not going to reduce down. If it reduced down, we would reduce it down. Right? So we distribute through, we solved it. And by the way, this is called a conditional equation. And there are 3 types. We'll talk about those in a moment. But this is called a conditional equation because you get an answer. Now, what's an expression? An expression, well, an expression has no equal sign, and it can't be solved. Here's some examples of expressions. (4x minus 9). 5x squared minus 3x. Okay. Those are expressions. Now, we cannot solve these. Why not? We cannot solve them because they don't have an equal sign. We're not going to focus much on expressions. We do use expressions a little bit later on in the course. But in this chapter, we're going to be focusing all on equations like these. Once in a while, we'll talk about expressions, but we're going to mostly focus on equations. Now let's do some more definitions. So we've talked about equations. They have an equal sign. Expressions do not. Now let's talk about linear and nonlinear, bless you, linear and nonlinear equations. Let's talk about the difference. Linear equations they don't have any roots, so they have no roots or powers on the x. And x is not in the denominator of a fraction. So no roots or powers on the x, and x is not in the denominator. Now, everything you've covered in previous courses is linear, for the most part. The last part of intermediate, you might have covered some nonlinear ones, but mostly it's linear. These are examples of linear. 5x plus 9 equals 2. 7x equals 2x minus 3. Here's another one. How about minus 8x equals minus 5x plus 4. These are all examples of linear equations. First off, do I have any x squareds or x cubed or any of that? No. Do I have any square roots with these? No. Is x in the denominator of a fraction? No. These are linear. When you graph them, they're a line. What about nonlinear? This is what we're going to be covering next week, is nonlinear. This week, though, we're going to focus primarily on linear equations. What about nonlinear? Okay, nonlinear, they have roots or powers. It's easier if I just look at examples, but they have roots or powers. So these are all nonlinear. The square root of x minus 3 equals 2. Okay, now, why is that one nonlinear? It's nonlinear because it has a square root. Okay? Anytime you have a root, it's nonlinear. How about this one? How about x squared plus 6x equals 9? That is also nonlinear. What makes it nonlinear? The powers. Let's do another one. How about 4x plus 9 over 7x minus 2 equals 5? That also is nonlinear. What makes this one nonlinear? 7x minus 2 below. I'm going to now give you two of these, and you're going to tell me if these are linear or if these are nonlinear. So I'm going to give you two of these, and you're going to tell me if these are linear or if these are nonlinear. Linear or nonlinear? Can someone tell me if this is linear or nonlinear? Nonlinear. What makes it nonlinear? Yep, the power. So this x squared right here, that's what makes it nonlinear. So this is nonlinear. What about this one? What about 4 times 3x minus 7 equals 5x? Linear or nonlinear? Do we have any squares or any cubes? No. Do we have any square roots? No. Any fractions with x down below? No. So what would this one be? linear. Okay. One more just to make sure, and this is just like your homework. Linear or nonlinear on this one. It doesn't matter what it is. You just look and see if you have powers or if you have square roots. Do you have either powers or square roots? No. So this one only has x's. So what would this one be? Linear. And as you can see, it's very, very similar to question 12, right? And same thing with 13. What would 13 be? 13 would be what? Non-linear, right? 12 would be what? Linear. We just need to make sure that we understand the terminology. Now we're going to talk about how to solve equations and the three types. The three types of equations are conditional, contradiction, and identity. So let's talk first about conditional. So conditional equations, they're equations that can be solved for a solution. So they can be solved for a numerical answer. So they're going to be able to be solved for a numerical answer. So that means we get a number. And about 95% of all equations that we solve are going to be conditional. So here's an example of a conditional equation. We did one before. The first one that we worked with was conditional. But let's do another one. And this one's got fractions on it. So let's review how to clear out and work with these fractions. Okay, we're going to talk about fractions. And I picked this one. This is a pretty easy one to work with that has fractions. And how would we approach this one? Well, fractions a lot of times, they cause problems for students. So what I usually have you do is I have you clear them out. That's going to be the easiest way, is to just get rid of them. Okay? We'll see them at the beginning, but they cause anxiety, so we're going to get rid of them. So the first step we do is we get rid of them. Now we look at this as like the least common denominator. And we look at our denominators here. We have a 3 and we have a 5. So what's the least common denominator of 3 and 5? Can anyone tell me? 15. So now, how do I clear out these fractions? Well, I need to multiply everything by what now? The 15. Okay. We'll do a couple of these just to make sure we're comfortable clearing out our fractions before we move on. When I multiply by that 15, what happens to my fractions? They're going to cancel out. Now, what do? We take that 15, we divide it by the number down below, that's called the denominator, multiply it by the number on top, that's called your numerator. So divide and multiply. It's that easy. So 15 divided by 3 is a 5. 5 times 4 makes it a 20. Bring down your x. Next, 15 divided by 5. Right? 15 divided by 5, that's a 3. 3 times 2 makes it a 6. That's gone. 15 divided by 5, that's a 3. 3 times 3 makes it a 9x. Don't forget the x, about the x there. And then 15 times 1, well, that is a what? 15. Now, fractions are all gone. We should now be able to easily solve it, which we can. Now, what's going to make this one conditional is we're going to get a number answer out. We're going to get x equals some number. Whenever you get x equals something, that is called conditional. So let's finish this one out. And we can do multiple steps at once. So I'm going to move that 9x over with subtraction. And I'm going to move the 6 over with subtraction as well. So now what do we have? We have 20 minus 9. Well, 20 minus 9, that makes it a positive 11. The 6's cancel. The 9x is cancel, right? And now we've got 15 minus 6. Well, 15 minus 6, that makes it a 9. How do we finish it? We should all know what to do. We divide by what? 11. And so now what's my answer? X equals 9 over 11. Pretty simple, pretty easy to work with. Okay, so we cleared out the fractions and solved it. And this is conditional. And why is it conditional? Because we have an answer. Whenever you solve it and you get an answer, it's conditional. Let's do another one. I want to do one more with fractions like this. And then we'll talk about how to use cross multiplication to clear out fractions as well. Okay, so let's do another one of these. And I'll just change up the numbers. And again, the directions are going to be solved. So how about I have you solve this one? How about 2/9x plus 3/4 equals 1. How about 1/3 x minus 3/5? So what we're going to try and do is we're going to try and clear out these fractions. Now, I've got lots of denominators, so I'm going to work with them in pairs. We've got to work with all 4 of these different denominators. So we're going to do them in pairs. It doesn't matter how we pair them up. We're just going to work with them. So we've got the least common denominator of 9 and 4. What's the least common denominator of 9 and 4? Do 9 and 4 have anything in common at all? No, right? 9's got what? 3 and 3, right? That's the only way it factors down. 4 has what? 2 and 2. They have nothing in common, so the least common denominator would be 9 times 4, which is a what? 36. Okay, we'll keep track of that one. And what about the next 2? Okay, so we did 9 and 4. Now let's look at the least common denominator of 3 and 5. Well, the least common denominator of 3 and 5 would be what? 3 and 5 would be 15. Now, we need to clear all of these out. So to do that, we need to find the least common denominator now of, and I'm going to show you how to do this, 36 and 15. So how do I find the least common denominator of 36 and 15? Well, they're pretty large numbers, right? Here's how you do it. Here's the absolute easiest way to do it. You start with your largest number. So in this case, what's the largest number? Okay, it's 36. So we see if they divide evenly first. So 36 divided by 15. Does that work? No, didn't go in evenly. So then we double it. 36 times 2. That's 72. Does that go into 15? Nope. 36 times 3. What's that? 108. Does that go into 15? Nope. 36 times 4. 144. Does that go into 15? Nope. What about 36 times 5? That's 180. Does that go into 15? Yes. It goes evenly into it what? 12 times. So what's the least common denominator? 180. Again, how did I do that? I started with a 36. And I said 36 times 2, 72. Doesn't go into 15. 36 times 3, 108. Doesn't work. 36 times 4, 144. Doesn't work. But 36 times 5 is 180, and that does work, right? So what's the least common denominator? 180. Now let's clear our fractions. And I specifically made this one a little bit more challenging than what you're going to see in your homework. Most of the time you just have 3 denominators. I made this one with 4 different ones just so you get a feeling for how it works. Now it's not that difficult because we have a calculator. It seems like we've got these large numbers, which we do, but that's okay because we have a calculator. If in doubt, use your calculator. So we need to now multiply everything by 180. And again, I specifically made this one to have a little bit larger numbers than what you normally have, just so you have an example of a more difficult. Now, what do? Divide and we multiply. So I'll put the calculator up on the screen so we can see what we've got. We take the 180. Move it so we can see. Here we can see it. We've got the 180. We're going to have to do what? Divide it by 9. So that's 20. And then multiply it by what? 2. That makes that piece then what? 40. So that is 40x. Next piece. Same concept. 180. Divide that by your 4 down below. Multiply that by 3, and what do we get? 135. Don't ever hesitate to use a calculator. If you struggle with mental math, that X there. If you struggle with mental math, use a calculator. Yeah, and I actually copied that X and that shouldn't be there, right? We don't need that extra piece. What's the next one? Okay. 180, divide that by what? 3. That's 60, and 60 times 1 makes it a what? 60x there. And the very last one. What's the very last one? 180, divide that by 5. That's 36 times 3. That's a 108. Now make sure you watch your signs. So that's going to be a negative 108. Fractions are all gone. We can deal with this. Let's work with it. So move that 60x over. That leaves you with a minus 20x. And you can do it in multiple steps or just one step, doesn't matter. So minus 20x plus 135 equals a minus 108. We'll move that 135 over. And again, you can do this in one step, or like I'm doing, multiple steps. And now we've got a minus 20x equals. Those go together. 108 and 135, they add together. They give you a minus 243. We'll divide by our negative 20 there. And what do we know about a negative divided by negative? Negative over negative makes it positive. And sometimes they'll reduce. Many times they won't though. Now, How can I see that this is not going to reduce? I look at my 243. Okay, 243 is an odd number. Down below we have 20 and it's an even number. So they're not going to have 2's in common. This has a 5 and a 10. The top one doesn't have a 5 or a 10. So those are not going to reduce. So I would just leave that then as 243 over 20. And that's it. Now again, it is a little bit more complicated than some of the questions that you might see, but there are a couple that are about the same level of difficulty. You just clear out the fractions. Once you clear out the fractions, it's easy. Let's try another one. This one requires a different technique. And this, by the way, is conditional because we have a solution. But let's learn another technique. Now, how would I solve this one? Well, we're still going to clear out the fractions, right? But I can use a different technique. Because what do we know about the fractions? One is on each side, right? And they're complete fractions. So, as many of you might remember, I can use what's called the cross multiplication technique. Because they're complete fractions, I can cross multiply. So when I cross multiply, I get now 2 times 4x plus 3 equals 6 times 5x plus 9, right? Simple. Cross multiply. Whenever you have a fraction equaling another fraction, cross multiplication works. But they have to be complete fractions. Now, I can finish it by doing what? Yep, distributing through. And when I distribute through, 2 times 4, that makes it an 8x. 2 times 3, that makes it a 6. 6 times 5, that's a 30x there. And 6 times 9, that makes it a 54. Okay. And I'll slow down a little bit so we can get caught up. But again, this is called cross multiplication. Now, when does it work? It works when you have a fraction equaling another fraction, right? So it works here, but it wouldn't work on the other one because you have all those different fractions. It has to be a complete fraction equaling another complete fraction. Now we can finish this because what do we need to do? We need to get the x by itself on the left. So I'm going to move that 30x over. And I'm going to move that 6 over as well. So you can do 2 steps at once, or you can split them out. Either way. It just depends upon how comfortable you are with combining steps together. So now we've got 8 minus 30. Is it going to be a positive 22x or a negative 22x? Which one? Negative. Okay, why is it going to be negative? Here's the most commonly made mistake. Students get in a hurry and they drop a sign. Which one is larger, 8 or 30? 30 is the larger one, right? What's the sign of the larger number? Negative. So you subtract them and you get your 22. So it's going to be a negative 22 because your 30 is the larger number and it is what? Negative. But where do students make a mistake? They get in a hurry, they subtract them, and they write down 22x. I see it happen all the time. The most commonly made mistakes that students make are small little sign errors or maybe adding or subtracting incorrectly. So be very careful. Take your time when you work these out. I see it happen with multiplication, addition, subtraction. Those are the most commonly made mistakes. So let's go ahead and finish this one out. Now, what about the other one? On the right-hand side, we've got positive 54 minus 6. Is that going to be a positive 48 or a negative 48? Which one? It's going to be a positive 48, isn't it? Right? Why is it going to be a positive 48? Because which one's larger? 54 or 6? 54 is the larger number, right? And when you subtract 54 from 6, you get 48. Larger number, positive there. Now, finish it by dividing, and you're going to have to reduce. So we're going to go ahead and reduce this down. I always bring the negative up to the top. And what do we know about 22 and 48? These are even numbers, right? So we know both of them are divisible by 2. We'll start with 2, and we can go further if we need to. But we know they both have a 2 in them. So 48 divided by 2, that's a 24. I'm going to bring my negative up with it. And what about 22? Okay, 22 divided by 2 makes it a what? 11. So that's about as far as I can go. Because 11 is a prime number, and it's not going to reduce down. So that's how you clear out fractions. I want to do one more. I want to do one more just to make sure that we're comfortable clearing out fractions. And then we'll move on to identity, contradiction, and then literal equations from there. So let's try and solve this one. 4x minus 5 over 7 plus, let's say, 1/3 equals 5. I picked this one on purpose because what we're going to have to do with this first fraction here, all right, is we're going to have to split it up. So I'm going to have to take this first fraction and I'm going to have to split it up into the 2 individual fractions. And then we'll clear them out. So make this one fraction into 2. So rewrite this now as 4x over 7 minus 5 over 7 plus 1/3 equals 5. Is everyone all right with what I did there? Okay, because when we have single fractions and complete fractions like this one, we've got to split it up to get individual fractions, and now we should know what to do. Now we need the least common denominator of 7 and 3, and what's the least common denominator of 7 and 3? 21. So everything's its own individual fraction. So multiply everything now by 21. And see what we're left with. Divide, multiply. So 21 divided by 7. 21 divided by 7 is a 3. 3 times 4 makes it a 12x. Don't forget the x there. 21 divided by 7 is a 3. 3 times a negative 5, well, that makes it a negative 15. 21 divided by 3. All right, 21 divided by 3 is a 7. 7 times 1 makes it a 7. Here's the most commonly made mistake. I guarantee that someone is going to write 5 here. It's not 5 though, is it? It's 21 times 5, which is 105. But that is one of the most commonly made mistakes, is simple things like that. Students forget, and I even like to draw arrows so you see it, right? Students forget that that 21 has to go through the whole numbers as well. So that's why I draw arrows. I think it just makes it easier so I don't lose track of things. Because again, in mathematics, it's all about being neat and organized. Now what do we need to do? Well, now we're at a point that we can solve it. So we're going to combine. I'm going to put the 15 and the 7 together. 15 is a bigger number, so it's going to make that negative. So we have 12x, and we have a minus 15 and a positive 7. That gives you a difference of a negative 8 there, and that equals 105. We're going to add 8 to each side. And now we've got 12x, and that 12x now equals 105 plus 8. That's going to be 113. And we'll divide by your 12. And that gives me x now equals 113 over 12. And that's as far as you can go, right? Is everyone okay with how to work with the fractions now? Decimals you should know how to work with. So we're not really going to go over too much with the decimals because you just use your calculator. There's only one of them in your homework. Now, so far, we've only talked about one type of equation. The next two types of equations that we're going to cover, we don't see that often, and they are conditional and contradiction. Or not conditional contradiction, identity and contradiction. So let's start with the identity. Identity means the sides are the same. So they're going to be the same on both sides. This is a true statement, and your solution is all real numbers. But the key takeaway here is they're the same on both sides. So they're going to be the same. Now, how do I remember that? When I think of identity, I think of identical twins. Okay? What do we know about identical twins? Identical twins are the same, right? So when I see identity, I think of identical twins. They're the same. In mathematics, when we talk about identity, we're talking about the sides being the same. So if the sides are the same, it's an identity. Now, when we solve this, we're going to come out to be the sides are going to be the same, and the solution is going to be all real numbers. They might not look exactly the same to start with, and we may have to do a little bit of algebraic manipulations to get them to be the same, but they're going to be the same. So here's an example of an identity. How about 5 times 3x minus 2 equals 12x minus 7? How about plus 3x minus 3? Okay. Now, right now, these don't look the same on each side, but they are going to be the same because when I distribute the 5 through, let's work on the left-hand side first. When I distribute the 5 through, what does that give you? 5 times 3, that's a 15x, and 5 times a negative 2, well, that's a negative 10. Right-hand side, 12 and 3, well, combine like terms, 12x and 3x makes it a 15x, and minus 7 and minus 3, that makes it a minus 10. These are the same, and if they are the same, then this is an identity, and the solution set is all real numbers. So that's an identity there. And what am I looking for the answer on this one? This is the answer right here. Identity, all real numbers. You can also write negative to positive infinity, and that's okay. I usually write it out as all real numbers because that's what your textbook uses. So I try to be consistent with the textbook. Let me go ahead now and pick one out of our textbook to look at. Out of 1-1, that is an identity. Sometimes I make up questions. Sometimes I do pick them from our textbook. We'll pick out one now that is an identity. Let me find one here. Let's see. How about we look at... let's do another fraction one. On page 111, question 32. I'll write it up if you don't have your textbook. Okay, so page 111, question number 32. So this is what we've got. How do we handle that fraction in front? Well, we just simply distribute it through. And this is going to be a simpler one. And most of the time they will be. Okay, when I distribute through, what happens here? What's half of 6? Okay, so that comes out as a 3x there. And what's half of 20? 10. So the fractions are gone, right? So that's going to be easy enough there. So the left-hand side is 3x plus 10. Now, what about the right-hand side? Distribute that 2 through. And that's x plus 4 plus 2x plus 6. And those can go together. And that makes it a 3x, and 4 and 6 goes together. That makes it a 10. And what do we notice now about the sides? Are the sides the same? Yes, these are the same. So this would be an identity. And if it is an identity, the solution is all real numbers. Now, what's the last type? The last type of equation is a contradiction. So a contradiction is basically a false statement. It's a false statement. It has no solution. And we represent that with the empty or the null set, with the 0, with the slash through. Now, how do I remember contradiction? Okay? I think of going to court. And if I go to court and I testify and the lawyer says, we think you gave contradictory testimony. If they say you give contradictory testimony, what does that mean? That means you lied, right? You gave a false statement. You said something wasn't true. So contradiction, I think of contradictory testimony in a court of law, and that means a false statement. That means we lied. So contradiction is something that's not true. It's a false statement. Now they may look like it's going to have a solution, but when you actually solve it, it doesn't. So here's an example. How about 4 times 2x plus 9 equals about 8x minus 12. So we'll do a pretty easy one here. And this is a very, very easy one to look at. It's not going to be an identity because they're not going to be the same, because when we distribute this 4 through, we get 8x, and 4 times 9 is a 36, and the other side is an 8x minus 12. Now, unlike the identities, what happens when I try to move that 8x over? Well, when you move that 8x over, it's going to make the variable disappear. So when I move that 8x over, I'm now left with 36 equaling a negative 12. And does 36 ever equal a negative 12? No. So this is false, so it has no solution. And it's a contradiction. So it's false, no solution, and we call this a contradiction. So that's a contradiction, no solution. We've got one more type of problem to look at, and we cover these in more detail when we get to chapter 2. But we're going to go ahead and talk about it a little bit now, and we're going to talk about literal equations. And a literal equation, in very basic definition, is an equation that has more than one variable. So an equation that has more than one variable is going to be called a literal equation. And where we primarily use this is in graphing. Here's a couple of examples, and I gave you 2 of these in your homework to look at. And I'm going to have to tell you what variable to solve for. So you're going to have to solve for the variable y. So we're going to be solving for y. So how about I give you 4x plus 5y equals 2. Now, you have done this before. In your intermediate algebra course, when you took an equation and you solved it for y, that was, remember, slope-intercept form, right? So that's what we're going to do here. We're going to solve this for y. It has 2 variables. That's why it's linear. Or sorry, not linear, literal, because you have 2 variables, so that makes it a literal equation, and we're going to solve this for y. So we move that 4x over, and now we've got 5y equals a minus 4x plus 2, and we want to solve this for y like it's going into slope-intercept form, so we divide everything by a 5, and reduce it down if possible. This one's not going to reduce down, so now we just rewrite this as y equals minus 5/4 x, or sorry, a 4/5 x there, and a plus 5/2. So that's going to be your solution, and we went and solved this for the variable y. Okay. In chapter 2, you're going to learn that this is called slope-intercept form. Right? You've done it before. Let's do another one. Let's do one with a negative and one that'll reduce down a bit. So again, we're going to solve for y. And let's say I have a minus 3x minus 7y equals 9. You've done this before in previous courses. This is, again, slope-intercept forms, what this is. So let's go ahead and finish this out. I'm going to add the 3x to each side. And now we've got minus 7y equals 3x plus 9. And how do we finish this out? We divide everything by a what? Negative 7. And whenever you have a negative, you want to rewrite it. So the negative comes up to the top. So y now equals a minus 3/7 x and a minus 9/7. And if you were in chapter 2, you could graph this because this would be your slope and this would be your y-intercept. But that's a later on chapter. That's chapter 2 when we go to graph these lines. So now we've finished all the equations out of 1-1. We do need to talk quickly about interest. So we're going to talk now about simple interest. And this is still 1-1. We may not get to 1-2 like what I had wanted. If we do, we may just cover a little bit of it. We'll probably keep that for next time. But let's go ahead now and talk about simple interest. Simple interest is I equals PRT. When we get to chapter 4 and 5, we'll talk about compound interest. But we're only going to talk about simple interest today. And so simple interest is very easy to calculate, and it's your I equals PRT. Now let's talk about what each one is and how this is going to work. I is the interest earned. P is the principal. The starting amount. R is the interest rate as a decimal. And T is a number of years. Now, when we talk about the number of years, if it's months, divide by 12. Right? 12 months in a year. If it's quarterly, divide by 4. So those are the two main ones, months and quarters. You could also have semi-annually, and that would mean divide by 2. But when we talk about time, we have to make sure that it's in terms of years. So if they give you months, you're going to have to divide it by 12. If they give you quarters, you're going to have to divide by 4, right? So make sure you're very, very careful when you read through these questions. Sometimes it's years already. Sometimes it's in terms of months or even in quarters. So now I'm going to give you one for us to work through. And there's 2 homework questions about these, 14 and 15. If $12,000 is invested at 8% for, let's say, we'll do an easy one here. How about 24 months? what is the interest earned and total amount? And I made this one easy. We'll do one that's going to come out to be a whole number. We'll do one that still has a fraction left. But here's what we've got. $12,000 is invested at 8% for 24 months. What is the interest earned and the total amount at the end? So let's go through our pieces. First off, we don't know the I. So that's going to be the question mark. So we don't know that. We know the principal P. Well, how much did we start with? We started with $12,000. We have an interest rate of 8%. And as a decimal, that's 0.08. And then we have a time, T. Now, we did not invest this for 24 years, did we? We invested it for what? 24 what? Months. So what do we need to do? We need to take this 24 and we need to divide it by what? 12, and that gives you 2. So what would my interest be? When we plug the numbers into our formula, we just multiply these together. So 12,000 times 0.08 times 2. And that gives me now an interest earned of $12,000 times 8% times 2 years. That gives me $1,920. So the interest is $1,920. So there's that piece. What's the total amount? Well, the total amount is going to be the $12,000 plus $1,920, and that gives me now a total of $13,920. Very, very important, though, months. Let's do one more, and this will be our last question. So I'll go ahead now and pass out the sign-in sheet. So here's the sign-in sheet. Everyone's name should be on here, hopefully, unless you enrolled after Friday. I printed this off on Friday. So if your name's not on here, but you enrolled after Friday, you're still in the course. So make sure you find your name on there. If you enrolled way last week, sometime early last week, and your name's on the roster, be sure and ask me, and we can see why. So let's do one more. And this will be our last question, and then we'll talk about our homework. So on this one, let's say if $5,000 is invested, it could be borrowed. Doesn't matter whether it's borrowed or invested, it's the same. For 7 months at 6.5%, what is the interest earned and the total amount? Now this one is going to give you fractions. When we work this out, what we want to do is we want to keep the fractions until the very end. And the last thing we do is divide. If you divide too early, you're going to round. And you're going to end up being off by 10 or 15 cents. So when we work this out, we want to make sure we keep the fractions until the very end, and then we round to the nearest cent. So let's think about what we need. $5,000 is invested. So that means our principal is going to be $5,000. Okay, so 5,000 is the P. Our interest rate is at 6.5%. So 6.5% as a decimal would be 0.065. And then we've got our time. Now, what is our time? 7 months. So that's 7 months. So that's 7 over what? 12. We're going to keep the fractions until the very end. So let's write up our formula. I equals PRT. So that's I equals now the 5,000 times 0.065 times 7/12. Do not turn this into a decimal yet. What I want you to do so that you get the exact answer is I want you to write all of this over 1. And we're going to multiply it. So you take your $5,000, multiply it by 0.065, and multiply it by the 7. That gives you that number. So multiply all those together. So that gives you 2275, and 1 times 12 is 12. Now, once you have done that, the very last thing that you do, so that you get the correct answer, very last thing is divide. So very last thing is divide that by 12. And we're going to round to the nearest cent. So what is it going to be? It's going to be $189.58. I did not round until the very, very end. So that is the interest. Now, what is my total amount? What is my total amount? Well, the total amount is going to be that 5,000 plus $189.58. Adding those together, my total amount is $5,189.58. If you divide too early, you're going to be off by a few cents. So don't ever divide into the very last step. Write it out, multiply across, and divide. Okay, so what's our homework going to be? Just so we know, our homework for Thursday is going to be 1.1, and we should be able to do them all. So that's your homework. We didn't get to 1-2 like I had wanted, but that's okay because we'll cover that on Thursday. But your homework is 1-1, do them all. If you've got questions, we'll go over them next class period. Next class period, we'll start and finish 1-2 and go over questions out of 1-1. So I will see everyone then on Thursday. Now, please make sure that you sign that sign-in sheet. So that sign-in sheet's floating around somewhere. Before you leave, make sure you sign the sign-in sheet. I think it's up here. If you want to see the videos, you can go online after class. I'll have them up this afternoon. And you can see the video that we covered today, as well as the lecture notes. And those will be in Canvas.